Imagine cracking open an egg and finding something that looks like it was pulled from a horror movie. The white has turned into a dark, translucent jelly the color of black tea. The yolk is a deep gray-green, creamy and dense, with a faint pattern of white, crystalline snowflakes branching across its surface. It smells sharp, almost sulfuric. And across most of East Asia, this is considered a delicacy. The Western world calls it a century egg. The name suggests something ancient, decayed, buried and forgotten underground for 100 years. The internet calls it something worse. In 2011, CNN conducted a poll of the most revolting foods on the planet. The century egg ranked number 1. Above bull testicles, above bat soup, above every other food from every other culture on Earth. But here is the thing that almost nobody outside of China understands. The century egg is not rotten. It is not decayed, fermented, or spoiled. It is the product of one of the most precise and elegant chemical transformations ever applied to food. And its story reveals something fundamental about how we decide what counts as disgusting and what counts as sophisticated. To understand the century egg, you first need to forget everything the name implies. In Chinese, it is called pidan, which simply means skin egg, a reference to the clay coating used during its preparation. Other names include songhuadan, meaning pine flower egg, because of those delicate snowflake patterns that form on the surface of the white. None of these names suggest age, rot, or decay. That narrative is entirely a Western invention. The origin of the century egg traces back roughly 600 years to the Ming Dynasty. The most popular legend says a farmer in Hunan province discovered duck eggs that had been sitting in a slaked lime pit for about 2 months. Rather than throwing them away, he tasted them. What he found was not rot. It was something entirely new, a flavor that was rich, complex, and unlike any egg he had ever eaten. Word spread, techniques were refined, and within a few generations, the century egg had become a staple across China. But what was actually happening inside that shell? This is where the story becomes remarkable. The century egg is not a product of decomposition. It is a product of alkaline chemistry. And the process is so precise that food scientists today still study it as a model of protein transformation. The traditional method begins with a paste. Producers mix clay, ash, salt, quicklime, and rice hulls into a thick, mud-like coating, then carefully pack it around raw duck eggs by hand, building up a layer roughly 2 centimeters thick. Each egg is then rolled in rice chaff so the coated eggs do not stick together, and the entire batch is sealed in large earthen jars or woven baskets, sometimes buried underground where the temperature stays cool and constant. Then comes the waiting. Depending on the recipe and the season, the eggs sit undisturbed for anywhere from 4 weeks to 5 months. No bacteria are involved, no mold, no fermentation in the traditional sense. What drives the entire transformation is a single variable, pH. The alkaline compounds in the paste, primarily calcium hydroxide and sodium hydroxide, slowly penetrate through the porous shell and raise the pH inside the egg to somewhere between 9 and 12. For reference, pure water has a pH of 7. Household bleach sits around 12.5. The interior of a century egg approaches the alkalinity of an oven cleaner. At this extreme pH, the proteins in the egg white begin to denature, not through heat the way a boiled egg cooks, through chemistry. The long chains of amino acids unfold, rearrange, and rebond in new configurations. The egg white solidifies into a gel, but instead of becoming opaque white like a cooked egg, it turns translucent and amber, eventually darkening to a deep brown or black. The texture becomes firm but yielding, almost like a savory jelly. The yolk undergoes an even more dramatic change. The fats and proteins interact with the alkaline solution, producing hydrogen sulfide and ammonia. These are the same compounds responsible for the smell of volcanic springs and cleaning products. In small concentrations inside the egg, they create a pungent, complex aroma that is central to the century egg's flavor profile. The yolk softens to a creamy, almost custard-like consistency, and its color shifts from yellow to dark green and gray as iron in the yolk reacts with the sulfur compounds to form ferrous sulfide. The same chemical reaction that produces the green ring around an overcooked, hard-boiled egg. Think of it this way. When you boil an egg, you use heat energy to rearrange proteins. A century egg uses chemical energy to do essentially the same thing, just far more slowly and with dramatically different results. Both processes are cooking. One just uses a stove. The other uses chemistry. And those pine flower patterns on the surface? They are crystals. As the alkaline solution penetrates the egg over weeks, magnesium and other minerals crystallize on the surface of the gel, forming intricate branching structures that look like frost on a window pane. In Chinese culture, these patterns are considered a sign of quality. The more elaborate the crystal formations, the better the egg. Producers spend years mastering the exact mineral concentrations and timing needed to produce the most beautiful patterns. It is edible art created by molecular physics. The modern process has evolved considerably. Most commercial producers today skip the clay paste entirely and simply soak eggs in a liquid solution of sodium hydroxide, salt, and sometimes zinc oxide for 10 to 14 days. The result is chemically identical but faster, cheaper, and more consistent. Industrial facilities in Hunan and Hubei provinces can produce tens of thousands of century eggs per batch using this method, supplying supermarkets across China and export markets throughout Southeast Asia. Some purists argue the traditional method produces a more complex flavor, the way barrel-aged wine differs from wine aged in steel tanks. The slow migration of minerals through the clay paste creates subtle variations in texture and taste that a uniform chemical bath cannot replicate. But the underlying chemistry is fundamentally the same. Now, here is where we need to confront an uncomfortable question. If the century egg is not rotten, if it is a sophisticated product of controlled chemistry, why does so much of the world find it disgusting? The answer has almost nothing to do with food safety and almost everything to do with cultural framing. Consider this. Some of the most celebrated foods in Western cuisine undergo transformations that are objectively far more disgusting than what happens inside a century egg. Cheese is curdled milk attacked by bacteria and mold. Blue cheese specifically relies on Penicillium roqueforti, a fungus that produces visible veins of blue-green mold throughout the product. Surströmming, the Swedish fermented herring, undergoes genuine bacterial decomposition and produces a smell so intense it has been banned from some apartment buildings. Limburger cheese smells the way it does because the same bacteria that cause human foot odor, Brevibacterium linens, are used in its production. Nobody calls aged Roquefort a rotten cheese in polite company. But the century egg, a product that involves zero bacterial decomposition, gets labeled as a rotten egg by default. This double standard reveals something deeper about how food disgust works. Psychologists who study the emotion of disgust have found that our reactions to unfamiliar foods are driven far more by visual appearance and cultural narrative than by actual chemistry or safety. We see a black, translucent egg and our brain immediately categorizes it as spoiled because in Western food culture, darkened eggs mean decay. The framing precedes the tasting. We have decided it is disgusting before we have taken a single bite. The 2011 CNN poll that crowned the century egg as the world's most revolting food triggered such a backlash in China that CNN eventually apologized and retracted the article. For Chinese commentators, the poll was not about food. It was about cultural ignorance masquerading as objectivity. How can you call something revolting that 500 million people eat regularly and consider a comfort food? And they had a point that went beyond hurt feelings. The century egg is not some exotic oddity consumed on dares or featured on Fear Factor shows. It is woven into the fabric of everyday Chinese cuisine in ways that Westerners rarely see or appreciate. Piden tofu, century egg with cold silken tofu dressed in soy sauce and sesame oil, is a summer staple eaten in homes and restaurants across the country. It is comfort food, the kind of dish people crave on a hot evening. Congee topped with sliced century egg and shredded pork is one of the most beloved breakfast dishes in southern China, Hong Kong, and Macau, served in everything from street-side stalls to five-star hotels. The combination of the silky, savory egg with the mild warmth of rice porridge is, for hundreds of millions of people, the taste of home. Chefs at Michelin-starred restaurants in Shanghai and Taipei use century eggs as a sophisticated ingredient, pairing their deep umami richness with pickled ginger, fresh chili, and crisp scallions to create dishes of extraordinary complexity. Nutritionally, the century egg is essentially a preserved egg with slightly elevated mineral content. The protein structure has changed, but the nutritional value remains largely intact. The sodium content is higher than a fresh egg, and traditional methods once used lead oxide in the curing paste, which raised legitimate health concerns. Modern Chinese food safety regulations have banned lead-based processing since the early 2000s, replacing it with zinc compounds that produce the same chemical effect without the toxicity. The century eggs sold in markets today are, by any reasonable standard, as safe as any other preserved food. But perhaps the most fascinating thing about the century egg is what it represents in the broader story of human food technology. Every culture on Earth has developed methods of transforming raw ingredients into something that lasts longer and tastes fundamentally different. Europeans mastered lactic acid fermentation with sauerkraut and yogurt. The Japanese perfected koi mold fermentation to create soy sauce and miso. West African developed alkaline processing for dawa dawa, a fermented locust bean paste that, chemically speaking, undergoes a transformation remarkably similar to what happens inside a century egg. The century egg belongs to this same tradition of human ingenuity. Hundreds of years before anyone understood pH or protein chemistry, Chinese producers figured out that wrapping an egg in an alkaline paste could transform it into something that lasted for months without refrigeration, developed entirely new flavors, and could be eaten without any further cooking. They did not have the vocabulary to explain what was happening at a molecular level. They just knew it worked, and they refined the process across generations until it became an art form. So the next time you see a century egg, with its dark, jewel-like exterior and its crystalline pine flower surface, consider what you are actually looking at. Not a rotten egg, not a culinary dare, but one of the oldest and most elegant chemical experiments ever performed in a kitchen. A 600-year-old piece of food science that most of the world dismissed before ever bothering to understand it. The real question was never why Chinese people eat rotten eggs. It was why we were so ready to call them rotten in the first place.